So now we will discuss about the blood pressure regulation. Okay, so how blood pressure is regulated. So the first thing is you have to understand blood pressure is regulated by a baroreceptor. Okay, and another is the chemoreceptor, and another is the RAS system, renin angiotensin aldosterone system. These are the three systems that control blood pressure. Okay, so the first thing is the baroreceptor, chemoreceptor, RAS. So we will discuss the baroreceptor. Baro mean pressure. Okay, baro mean pressure, and receptor mean that have special cell that receive the function that pressure is changing or not. So if this is stretch or not, so there are special nerve cell called sense blood pressure regulatory. Okay, sense blood pressure. How? First thing is, if the baroreceptor is, for example, this is the artery, if this stretch, okay, so it will sense. Okay, now another is the it due to this thing the blood pressure become balanced. Okay, so first of all you will tell the baroreceptor. There are baroreceptor are nerve ending, there are nerve ending. Okay, and nerve ending location, there are different location of the nerve ending. First is the arterial, another is the cardiopulmonary. Arterial and cardiopulmonary. So arterial are the aortic arc, present in the aortic arc and carotid sinus. Okay, in the how there is aortic arc, in the aortic arc there is the nerve ending. Okay, in the there is the nerve ending, for example vagus nerve. Okay, vagus nerve is actually the 10th cranial nerve, 10th cranial nerve. Okay, 10th cranial nerve. So this is the vagus, so it have a nerve ending on the aortic arc. Another is the on the carotid sinus. In the carotid sinus, this is the carotid sinus. In the carotid sinus there is a nerve ending. Okay, carotid sinus, there is the carotid sinus on internal carotid artery. Okay, and they have this nerve ending comes from the glossopharyngeal nerve. Glossopharyngeal nerve is actually nerve cranial nerve 9. Okay, and vagus nerve goes toward the aortic arc, and that is the 10th mean 10th. Okay, 10th mean the aortic. Okay, 10th 10th 10 aorta, aortic arc. Okay, 10R. And glossopharyngeal pharyngeal. Okay, P mean 9. Okay, P and 9 is same, just like same. So glossopharyngeal is come from the uh, nerve number 9. Okay, so the now if these nerve ending are present here. Okay, when how it can regulate the blood pressure. First of all, if the artery stretch, for example if this stretch, okay, so they give signal to this nerve, and this nerve goes toward the brain stem. In the brain stem there is a cardiovascular center. Cardiovascular center have different role. Okay, this is actually the brain stem. Okay, pons, nucleus tractus, solitarius, and medulla oblongata and pons. So from the cardiovascular center, when the nerve and the stimulus goes toward cardiovascular center, cardiovascular function have to modify the total peripheral resistance or cardiac output. For example, if the blood pressure is increases, okay, what can it do? It decrease the total peripheral resistance. Okay, so if total peripheral resistance decreases, the blood pressure also decreases. Okay, and cardiac output, so we will tell about how. So here is the baroreceptor reflex, and baroreflex occur in the second to minute. Okay, this is just the simple overview of the this. Now we will explain all the things one by one. Okay, so when the signal go toward the cardiovascular center, okay, cardiovascular center, what will do cardiovascular center? This is cardiovascular center. Okay, so it is present in the middle one third of the pons of the brainstem. Okay, it autonomic control of the cardiovascular center and vascular function, coordinate sympathetic and parasympathetic. This is actually the function of the cardiovascular center. Another is called, so first of all there is a vasomotor center. This is actually the vasomotor center, you have to understand. This is the vasomotor center. Okay, this is the vasomotor center, vasomotor control center. It for example sympathetic nerve fiber control the diameter of the blood vessel. It controls the diameter of the blood vessel. Another is the cardiac accelerator, cardiac control center. cardiac control center. This is actually the cardiac control center. Okay, this is actually the cardiac control center. And cardiac control center have two central. One is the cardiac accelerator, another is cardiac deaccelerator. Cardiac accelerator increase the heart rate, contractility, and by sympathetic outflow tract. But cardiac contractility is only increased by the cardiac accelerator. So the cardiac accelerator function also on the heart rate and also on the contractility. But the cardiac deaccelerator only decrease heart rate. It not decrease contractility, etc. Okay, it's only increase heart rate by parasympathetic outflow tract. So if the nerve, for example, the signal come toward cardiovascular center have, if if there is need that increase the if there is need to increase the heart rate, so the cardiac accelerator work and increase the heart rate and also increase the contractility. And what vasomotor function we will do to explain how it's working. Okay, now you have to understand that, for example, this is the glossopharyngeal nerve and this is the vagus nerve. Okay, vagus nerve, they supply, they, for example, they, if the blood pressure is increases, okay, higher the frequency, the higher the frequency, if the blood pressure is increases, higher the frequency of nerve impulse. These you have to remember this. If the change in the pressure is more, the frequency of nerve impulse also be more. Okay, in aortic arc. Now first thing is, for example, if your blood pressure is increases, you are running, etc. For example, a dog, etc. are moving toward you, and your blood pressure increase. So aortic arc becomes stretch more. Aortic arc is just like stretch. Okay, when that stretch, what will happen after that? The after, from the aortic arc, this is the aortic arc, and from this the signal go toward the baroreceptor, and baroreceptor fire. When the baroreceptor, there is the baroreceptor fire through the vagus and the glossopharyngeal nerve. The signal, the nerve impulse go toward the cardiovascular center in the brainstem. So now let's start that how it works. For example, if the blood pressure bring now toward the cardio, the nerve impulse goes toward the cardiovascular center and crying to them, please decrease my heart, please decrease my blood pressure, that my normal body function is not working, you have to decrease my pressures. Okay, so what the cardiovascular center do? The cardiovascular center just stimulate the parasympathetic nervous system. First of all, it stimulate the parasympathetic nervous system by how? By cardiac deaccelerator. There is a cardiac deaccelerator, and cardiac deaccelerator increase by they actually stimulate the parasympathetic, and cardiac accelerator, this is the cardiac accelerator, and cardiac accelerator inhibit the sympathetic. Actually cardiac accelerator function become decrease, so they decrease the sympathetic outflow, the sympathetic function. Okay, it decrease the heart rate and decrease the contractility. It is done by the cardiac accelerator, and cardiac deaccelerator increase the parasympathetic nervous system. Okay, now parasympathetic increase the cardiac deaccelerator by this is actually done by the cardiac deaccelerator, and this is done by the cardiac accelerator, and by combining both of them the cardiac output decreases. Okay, because cardiac output is equal to heart rate multiply by the cardiac output multiply heart rate and stroke volume. So heart rate, if the heart rate is decreased by here, okay, and stroke volume depend on the contractility. If the contraction is more blood goes out, more percentage of blood goes out, so cardiac contractility is decreased, so stroke volume is decreases, heart rate is decreases, so cardiac output decreases. Due to this, cardiac output is decreases. Okay, now if the cardiac output is decreased, the function will go toward normal. Now the second thing is the vasomotor center. The vasomotor center activate, and what it do, it decrease the vasoconstrictive. For example, this is the blood vessel. Okay, and here is the pressure is more. If the pressure is more, if you want to decrease the pressure, what can you do? You can have to vasodilate it. For example, increase the vessel diameter. If you increase the vessel diameter, the pressure will become decreases. Okay, if the pressure is decreased, if you constrict this blood vessel, the pressure is increases. So constriction increase mean constriction increase the pressure, okay, and vasodilation decrease the pressure. You have to remember this thing. So now the pressure is increase and decrease. So here vasoconstrict what will do vasomotor center if the blood pressure is increased? Vasomotor center decrease the vasoconstrictive effect. How? Actually, one thing is it decrease the total peripheral resistance. Okay, first thing it do like this. So the blood pressure is equal to cardiac output multiplied by total peripheral resistance. So if the total peripheral resistance is decreased, cardiac output is decreased by the cardiac accelerator and deaccelerator. So cardiac output is also decreased. Total peripheral resistance is decreased by vasomotor center. Okay, so the blood pressure is also decreases. This is simple, so simple. Okay, so blood pressure is decreased back toward normal. Now another thing is the arteriole is dilated. How vasoconstrictive effect done? For example, arteriole is dilated. When arteriole is dilated, the total peripheral arterial resistance become decreased, TPR decrease. Okay, and when constriction is also decreased, if for example when constriction is decreased, when have more blood can occupy in the vein, because vein have capacity to occupy more blood, so more blood go toward the vein and store it. Okay, because vein is also a storage site. Okay, so the second thing is the constriction of the vein is decreases. Okay, so blood pull to periphery, not to the heart. So to the heart there is less blood move, and less blood move, so the cardiac output and the stroke volume become less, and their blood pressure become decreases. So if the venous return decrease, preload increase. For example, if less blood come in, less blood move out, so the diastolic filling of the heart decrease the diastolic filling of the heart, and cardiac output is decreased. So if less blood move in, less blood move out, so the cardiac output is decreased. If the cardiac output is decreased, this is the cardiac output, the blood pressure is decreases. Okay, so this is vasomotor. So you have to now let's revise it. Okay, how you can revise it? Just go to just come here, that understand blood pressure is equal to blood pressure is actually blood pressure is equal to what? Is equal to cardiac output multiplied by total peripheral resistance. So cardiac output is decreased by vasomotor, this vasomotor center, and TPR is increased by cardiac accelerator, cardiac control center. One is the accelerator, another is deaccelerator. So if the blood pressure is increases, vasomotor in vasomotor increase the vasodilation, it do vasodilation. Okay, and cardiac accelerator, what do it decrease? Heart rate and contractility. Okay, and it mean cardiac output is increased. So just like this is simple things. Okay, you have to remember this about the blood pressure. Okay, and subscribe the channel, like the video. Thanks for watching.